Hello and welcome. My name is Michael Kosir. I am a developer advocate here at HashiCorp, and today I will be talking about how you can decouple secrets management from your Python web applications. Now, today's talk is going to focus on virtual machine-based deployments. So if you are hoping for containerized workloads on Kubernetes, unfortunately, that's not what the talk today is about, but we do have a lot of great content, blogs, videos, tutorials out there to help you with that journey. But anyway, back to our talk. So here is a common deployment pattern that I have seen for Python web applications. Users interact with an application server, and then that application server is sending requests to a number of your Python web apps. And it's called a pre-forking model because the app server actually forks multiple processes of your application. And it manages those applications. So you can tell the application server to reload the application, and it will gracefully stop any working processes and spin up new processes in its place. And those new processes will take new configuration, they'll take new secrets, and it allows you to very cleanly and without downtime replace your application. Now, there's a number of application servers on the market today. In my demo that I'll be showing later on is using gUnicorn, but there's also Apache Mod Python or even Nginx Unit. Now, there's two key things you want to keep in mind. You want a application server that can handle hot reloading its own TLS SSL certificates. And then you also want an application server that gracefully can replace worker processes without downtime. And so those two things are critical. A lot of application servers on the market do those things, but if you're definitely going down this path, you want to make sure that you're doing those things. Because the application server is doing a lot of the heavy lifting for us, that grants us the flexibility and freedom to choose any Python framework that we want to. And so, for example, in this demo, I am using Fast API, but you could also use something like Django or Flask. Now let's talk about secrets and Python web apps. So in this example, I have a virtual machine. It has TLS SSL certificates in a file. It has secrets in a file, and the application server is pulling the certificates, and each of the worker processes is pulling the secrets as well. Now we can implement Vault Agent here. And so Vault Agent is a standalone binary that runs in its own process alongside our application. And it manages the authentication and secret generation and renewal lifecycle or process. And we're running it alongside our application because we're decoupling it from the source code. So remember that this whole purpose is to keep our source code clean, simple, and elegant. And we do that by running a separate process. So we're kind of shifting secrets management from a developer process to an operations process. So the developer process or development process stays really simple, and there's a little bit more complexity on the operations side of things because we have to run another binary. But the cool part here that I have highlighted in red is that once the credentials change, Vault Agent can issue a reload statement, such as a SIGUP, and it will send that to the application server, which then will gracefully replace all of the worker processes, which then will get the new secrets. So that's it for the diagrams. Let's jump into a hands-on demo. So this is the demo that I will be showing. It's available here on my GitHub at Vault Python Web App. Feel free to follow along, or after the talk, after HashiTalk Secure, feel free to jump in, dive in, kind of dig into the code and see how I'm doing everything, because I won't have time to cover everything today. So let's jump over to VS Code. So here on the left-hand side, we are leveraging, this is our settings.py file. So this is setting up all of our settings for our application. And we are leveraging Pydantic settings to do a lot of the heavy lifting for us. So we have a number of classes that represent the various types of settings that we may have. We have app settings, AWS settings, database settings, Vault settings, and then we have our top kind of parent settings, which then has all of the other settings nested within it. And that just gives us a nice single settings object here. But scrolling back up to the app settings at the top, we can see that by using Pydantic settings, we can define where Pydantic should look for these configuration items. So here we're setting a name, an admin email, an API key for our app settings. And that's going to be looking for app.env. So we're going to leverage Vault Agent to generate that app.env file for us. And so on the right-hand side, we can see that this is app.env, the Consul template, which Vault Agent will use. So we're pulling from kv/demo, and we're storing those secrets into our environment variables here. And then for AWS settings, we have our access key, our secret key, and session token, and that's exactly what it looks like in the Consul template. So we're pulling from AWS STS example, and then we're storing the access key, the secret key, and the session token into the corresponding variables here. And finally, our database, again, we're pulling our username, our password, host, port, and database. This one's a little unique in that half of the data is coming from the KV engine, and then the other half of the data is coming from the dynamic database secrets engine. So we can see here the KV engine, kv/demo for static, and PGSQL creds demo for our dynamic credentials. Now for the demo, I have it set to a TTL of 10 seconds, which is very quick. Definitely for demo purposes. In a production environment, you may want to do 90 days or 30 days, depending on your organization's policies. But for demo purposes, I think doing 10 seconds is really nice, and we can see that here. So next we'll jump over to the Vault Agent configuration. So we can see that we're pointing it to a Vault cluster, which I'm just running locally. The next is our auto-auth method or stanza here, and this is just defining how we're going to authenticate into Vault. If you're running in the cloud, you could use the cloud auth methods, AWS, GCP, or Azure. But for my demo here, I'm just using AppRoll. Next, we have our various templates, and we have a template for each of our settings. We have our app.env, vault.env, and database.env. So we're pointing a source and destination for each of them. And then we can also define things like file permissions, the user, the group, who owns the file. And then the most important part is this command. So this is what do we do once new secrets exist? And so this is just saying, is the gunicorn process active? If it is active, let's reload it. Otherwise, we're just going to say true because otherwise we don't want to error out. So the true is just there so we don't error out. And we're going to do that for all of our templates here. And I do have the AWS one commented out because I don't want to accidentally leak any AWS credentials here. And at the very bottom, you'll see here that we have a PKI template as well. And it's doing the same thing. It's writing this to a specific cache, and we can take a look at that Consul template as well. So here is the Consul template markup language for this. So a little bit more complicated. We're pulling a PKI. We're issuing a certificate for our demo. We're telling it it's webapp.example.com, and our TTL is 24 hours. And now we're going to store, this is doing a little bit more advanced items here, but we're going to store all of these items into a cache. And then we're going to leverage these functions, the write to file function, to write specific items to other files. So we're going to write our key to server.key. We're going to write our cert to our server.pem, and we're going to append it with our CA, also to server.pem. And here we can specify, the user, the group, and then the permissions of the file. So this one's a little bit more complicated, but I thought I would just show it out here as well. So that's all of the code. Again, it's very simple. Our application, nowhere in our settings did we mention Vault. All of that is handled through an external process. Our Python web application is only calling these specific files, which very simplifies our Python web application. So now we'll jump over into terminal and we can do kind of a hands-on approach. So I'm going to run this. This is a load test against our application. So I'm going to run this test for 1 minute, and it's going to hit our application 200 requests per second. We're going to hit the DB users endpoint, and that's just going to pull users from our database, just to show you that we are, in fact, doing things. And then it's going to generate a nice, clean report. So I'll run this, and in the meantime, we'll hop over to this other tab, and we'll talk about the settings here. So here I have highlighted the database username and password. So what this whole page here is doing is a curl command against the sysinfo endpoint. And that's going to run every 2 seconds. And remember, our database credentials only last 10 seconds. So we should see these change every 10 seconds as I'm talking, right? So Vault Agent is pulling credentials. It's keeping track of the least, the max TTL. When credentials need to be recreated, Vault Agent generates new credentials and then stores them into the file and then tells our application server that new credentials exist, please reload the application. And so as I've been talking, we can see that the username and password here have been rotating every 10 seconds. And we can also see other things as well, our application name, our application email, API key, and our Vault various configuration items here if we wanted to use transit or transform engines for advanced data protection purposes. Additionally, because I showed the PKI engine, we can check that out here as well. So I'm going to run this curl command against our web application, and we can see that our subject is the webapp.example.com, which is what we had it set to. And we can see from our start date and expire date, these are 1 day apart, which was our 24 hours apart. Additionally, we can see that the issuer is our intermediate authority for our Vault, which is our intermediate authority here as well. So this was just a very quick and basic introduction to Vault Agent, PKI, dynamic secrets, static secrets, and everything. So all of this code is available out on GitHub. We will now jump over to our load test, and we can see that we ran 12,000 total requests, which was 200 requests per second. And we can see that 100% of them were successful, with our status codes being 200 for everything. So throughout this whole process of constantly changing and regenerating our database credentials and reloading our application, although we were hitting our application 200 times a second, we were still always online and always handling requests from our user. So that is about all of the time that I have left. Again, all of this code is out there on GitHub. There's even in the code, I can show you that real quick before I run out of time. There is a demo and a README. And so this README goes through everything you need to do in order to get this up and running yourself and hit all of the various endpoints. But with that, I will end it here. Again, it's on GitHub. Feel free to reach out to me on LinkedIn. My name is Michael Kosir, and it's been great. I hope you enjoy all of the other talks that we have here at HashiTalk Secure. Thank you.